welcome back. This is Fractions Part 2 of Math with Sensei Brian. In the last video, we covered the 4 functions of math when it comes to fractions. We also discussed reducing fractions to lowest terms. We also discussed for adding and subtracting fractions the least common denominator. Early on in the video, you also heard me say a fraction is more than just a part of a whole number, that sometimes it's an estimation of a whole number, and sometimes it's a ratio, and sometimes it's rise over run. So I'm going to explain something real quick to you, so just give me a second. Okay, before I go on, we need to understand this term, irrational number. Irrational is a number that repeats or has no end. A number that's a repeating number. 1/3 equals 0.3. We can ride around this room, wrap around 100,000 times. It has no end. 2/3, 0.6, forever. Pi, 3.141592656. When I was a kid, about 12, 13 years old, they had taken pi over 1 million places, and that was way back in 1982. Here it is, 2020. That's 38 years later. How many places have they taken and it still hasn't repeated? The square root of 3, 1.732050807757, and on and on and on. This is a number we use when we try to find phases, or actually trying to find voltage sometimes in electricity. That's why we'll do things like this. But the point being, these are all irrational numbers because they repeat forever, like these down here, or they have no discernible end. But I kind of want to focus on these two numbers down here. Right, so just give me a half of a heartbeat. Okay, 1/3 in decimal form is 0.3 forever. That's an irrational number. So 1/3 is actually an estimated or an agreed upon number. Well, 1/3 is 3 forever, or actually you can write it like this: 3/9, right? Because 1/9 equals 0.1111111 forever, right? Put that on a calculator. 1 divided by 9, 9 divided by 1 is 1 forever. Divide this by this, okay? So 2/9 would be 0.2 forever. 3/9 or 1/3 is 0.3 forever, right? 2/3 or 6/9 is 0.6 forever. Along that line of thinking, what is the real difference What's the real difference between this number written in decimal form and this number? Okay. The great scientists and mathematicians of the world at one point came up with an agreement. If there is no discernible difference, discernible meaning one you can see or manage or conceive, if there is no discernible difference between 0.9 forever, because theoretically that's what this is. If this is this, and 3/9 is 1/3 is this, 7s, 8s, 9s forever, that's how it will show up on your calculator. It will not show up as the number 1. So they've come up with the thing that if there is no discernible difference between 0.9 forever and the number 1, it is considered the same number. Considered. It's not the same number, but it's so minuscule that you can't conceive just how small the difference is. So a fraction sometimes is an agreed upon estimation on what a number is. 1/6, by the way, equals 0.166 forever. So it's an irrational number too. Okay? Fractions are oftentimes used to give a value to an irrational number, an agreed upon value to an irrational number. When it comes to physical properties, you have a pie here and you have 3 parts. Well, according to fractions, that's fine. But according to decimals, it isn't. According to the decimals, you never actually fill up the whole pie. So a decimal is a more exact number. A fraction is a more agreed upon number that you can use to write a decimal. So how do you convert fractions to decimals? Simple. If you have the number, let's go 3 over 4, right? What you do is you go we know that 4 won't divide into 3, so you add a decimal point. Add the 0. 4 goes into 37 times. 28. 10 minus 8, 2. Drop a 0. 4 goes into 5, 20. Right? There's your answer. So this equals 0.75. Okay? And that's how you do it. Divide this into that. That's how you turn a fraction into a decimal. Okay? This was rather easy. 0.75, 75 cents, 3/4, however you want to get it. But that's how you convert. If I did another number just for kicks and giggles, since that's what we're here for, is to make this fun, not so much just teach you, show you. So let's do another number. Say, oh, sensei, how about, let's say 11 over 32. Well, equals, well, you obviously go 32 into 11, and then you go 0, because you know 32 twice is 64. There's 3. So it's going to be this. See, let's see. 3 times 2 is 6. 3 times 3 is 9. 96. 10 minus 6 is 4. Oh, remember that, right? So 10 minus 9 is 1. So then obviously you bring this down. So probably 4. 4 times 2 is 8. 4 times 3 is 12, right? And 10 minus 8 is 2. 3 minus 2 is 1. Do we really need to go on with this? Right? So I'll do it one more time, right? So that'll be, this would be 24, right? We'll stop right there. But as you can see, you can go on and on and on. This number may go for a while before it stops, okay? But that's how you convert this into this, okay? You put this on the outside of the bracket, divide into this number, or divide this by that, right? And you'll get your fraction. You'll get your decimal. Wow. A true representation is always a decimal. An estimated representation or the agreed upon value would be a fraction. Rather simple. Okay. I also said that it would be a ratio. So I'm going to do this. Ooh, this is shameful. I'm going to go 1, 2, 3, 4. And I'm going to draw these green. Let's say 5, 6, 7, 8, 9, 10. Okay. You have 10 dots here, right? Of these 10 dots, 4 of them are blue, 6 of them are green. So you can technically write this out as 4 to 6, or for every 6 green dots, there are 4 blue dots. That's a ratio, 4 to 6, okay? Or if you want to, you can also say for every 10 dots, there's 4 blue dots, excuse me. We're going to do it this way to keep it colored so you don't get confused. We're going to say for every 10, overall, there is 4 blue dots. That's also a ratio, right? You can go 4 to 6, or for every 10, 4 of them is blue, or for every 10, 6 of them is green. That is a ratio. How does that come in handy? If you're making chocolate milk, it's called finite math. If you're making chocolate milk and you may have 1 quart of milk to maybe 3 tablespoons of chocolate, or however you like it. That's a ratio. That's finite math. That means, you know, it has to do with mixes. Anytime you have recipes, you're doing ratios a lot of times, okay? Oh, for 1 gallon of milk, you'll add maybe 3 pitchers of syrup or whatever. Ratio. You can write that as a fraction and you won't be wrong. So get used to that. This is going to take a minute, so give me a second. Okay. Now, at one point, I also said that this rise over run. So I'm going to show you what I mean. Here is a graph chart. Here's your x coordinate, your y coordinate. Here's your positive x's, your negative x's, your positive y's, your negative y's. Coordinates on the chart, right? So if I have an ordered pair of numbers, here's my x coordinate and my y, so I go 1, 2, 3 here, and I go up 2. So that's what this point is, 3, 2. Now, my rise over run would be up 4, because it's rising, over 3. So I'd go, let me put it in another color. You go 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4. So you here, 1, 2, 3, 4, right? 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Okay? So you go up 4 over 3. Up 4 over 3. Overall, it's going to look like that. That's and it'll go this way as well. That's called a slope. Okay? But you remember, you went up 4 because there's your rise. You went over 3. There's your run. You went up 4 more. There's another rise over 3. Up 4 over 3. Up 4 over 3. Up 4 over 3 ad infinitum, which means to infinity. Okay? So that's how fractions can also be written for graphs. Rise over run. Okay? So fractions are usually 3 things. An incremental part of a number, which is sometimes an estimated or agreed upon value for a whole part of a whole number. It is also a ratio between 2 parts of a number or 2 different values. Or it's used on a graphing chart to show the rise and run of a slope. By the way, this is a rising slope because it goes left to right. If it goes down, that's a descending slope. It's a negative slope. But we'll get into graphing later. But for right now, that's the basics of what you truly need to know about fractions. We've shown you how to reduce them. We've shown you how to convert them. We've shown you what they actually are and what they can actually do. So I had to split this video into 2. This video is going to run probably into 15 minutes. So the 2 of them combined is 35 minutes. That's a lot just basically for one subject. But that's the joy of math. There's so many parts to it. And it's actually kind of simple because all you have to do is break it down to where you understand it. Anything that's big can be broken down to where you understand it. Sometimes teachers don't have the time to teach you. Well, hopefully you can come see me and we'll have time to do this together. Please like, please subscribe, please share. If there are any comments, if I've made any errors, let me know. I will have no compunction to change them. No qualms, no nothing. Because we all make mistakes. We're all human. But hopefully this gives you the basic idea of what these things do. Okay? God bless you. I love you, Sensei Brian does. Be kind to one another. Remember, life is too short. We don't know when it ends. Treat each other kindly. We just elected a new president. That's all I'm going to say about that. So we're going to see what changes are going to be made. God bless you. Have a good day. And I'll see you on the next video.